The hidden penalty. Every single time Windows forces a background security update, drops an unmanaged network container wrapper, or triggers a silent driver timeout, your AI worker node drops completely offline. You are losing your queue position, getting hit with heavy network latency penalties, and bleeding your daily passive income simply because you are relying on an operating system built for office spreadsheets instead of enterprise-grade machine learning. The harsh reality of decentralized physical infrastructure networks is that the algorithm rewards absolute stability. When you host a worker rig on Windows, you are fighting a losing battle against a bloated operating system that treats your multi-GPU array as an afterthought. Today, we are permanently fixing your uptime score. We are leaving consumer operating systems behind and executing a complete professional migration to a headless Ubuntu server environment, the absolute gold standard for decentralized AI compute networks. The structural problem. To understand why your rewards are dropping, you have to understand exactly what Windows is doing behind the scenes. Windows runs hundreds of hidden consumer telemetry services, anti-malware executables, and graphical user interface overlays in the background. Most importantly, the Windows display driver model aggressively allocates and reserves over 2 GB of precious VRAM right from your graphics cards just to render the desktop environment. In the world of AI compute, VRAM is your primary leverage. By locking your system into Windows, you are actively shrinking your available Tensor cores, making it impossible for your RTX 30 and 40 series cards to accept larger, high-tier large language model training jobs. Worse yet, Windows handle network layer interactions through deep stacks of consumer middleware. When your DPIN node receives a sudden spike in data validation benchmarks, Windows frequently lags out the container interaction, triggering a silent network drop that disqualifies your rig from the active allocation pool for hours without ever showing an error on your monitor. The architecture shift. The solution is a total transition to a headless Linux architecture. Headless means zero graphical user interface. No desktop, no windows, no useless animations. Just raw, pure command line power dedicated entirely to feeding data to your graphics hardware. By utilizing Ubuntu Server, we strip the operating system overhead down to absolute zero. This immediately frees up that stolen VRAM, giving your deployment containers raw, unhindered access to the physical silicon. In this masterclass, you do not need to be a coding genius or a Linux system administrator. I have mapped out the entire deployment process into clear, logical steps. We will walk through preparing your boot media, flashing a clean server environment, configuring secure shell access so you can monitor your entire hardware array securely from any phone or laptop on your network, and locking down your system dependencies so updates never break your node stack again. Advanced node automation. Once the core operating system is active, we deploy the enterprise layer. We install the official production branch NVIDIA data center drivers directly into the Linux kernel, bypassing consumer limitations. Next, we establish the Docker runtime environment, creating an isolated, high-performance sandbox where your machine learning worker container can run at maximum priority. But we don't stop at just a basic installation. To guarantee your peace of mind while you are away from your desk, we deploy an automated systemd watchdog service running directly in the background. This custom watchdog script continuously monitors the health of your GPU communication lines and network sockets. If a decentralized network layer ever blinks or a container encounters a driver timeout, the Linux kernel doesn't freeze or blue screen like Windows. Instead, the automated script instantly triggers a soft reset of the GPU state and restarts the container services in milliseconds, auto-healing your connection before the network benchmark tier even registers a hiccup. Maximum allocations. The performance difference after making this switch is night and day. Your graphics cards run significantly cooler due to optimized kernel-level fan profiles. Your system latency drops to near zero, and your uptime baseline locks into the top tier of the network. With your VRAM fully unlocked, your node becomes a priority target for high-paying compute jobs, instantly maximizing your daily reward allocations and ensuring your hardware is running at peak profitability 24 hours a day, 7 days a week. Want the complete copy and paste command sheet to execute this entire migration in less than 15 minutes? Check the pinned comment below to access our free, dedicated code repository containing every single terminal line used in this tutorial. And subscribe to Kryptonite right now so you never miss an enterprise-grade hardware optimization strategy.